This video is going to cover section 7.2 and 7.3 together. They use the same calculator functions as 7.1 did, but with just one small difference, and the questions are worded differently. So now it's a normal population with a given mean and standard deviation. For 7.1, it was the standard normal curve, so that meant the mean was always 0 and the standard deviation was always 1. And these you're going to be given that. And so a lot of them are going to ask for the something or other percentile. A percentile is the same as area to the left. So we just get to do the fairly simple thing from 7.1 where we do inverse norm, and they're all going to be area to the left as long as it says it's a percentile. And the 83rd percentile means the area is going to be 0.83. And so now we have numbers to use for mean and standard deviation. So here we've got a mean of 53 and a standard deviation of 8. And we would leave it at left if you had those options, but most of the calculators default to left, so we won't have that line. Paste and enter, and it just gives you your answer. And so those are quite straightforward, not bad at all. So that's how all of these would be: 80th percentile, 9th percentile. This one says first quartile. First quartile is the same as the 25th percentile, so it would just be entering 0.25 as the area. It's the only difference there. In some of the other ones, it's going to give you, it's going to ask for what proportion or what is the probability. So for those, we're going to go back to using second var's normal CDF. And if it says more than, that's like area to the right. So then our lower bound is 123. We want trees more than 123, so we want 123 all the way up to infinity. So we're going to go back to using that 1E99. And then we've got the mean and standard deviation of the trees, 114 and 13. 114 and 13, and enter, and this gives us our proportion. Proportion less than 105 is same thing, but second var's normal CDF. But now our lower, this is an interesting one because you certainly can't have a tree that is negative infinity in height, but when I've tried it out, you end up with the same answer whether you put in 0 for the lower or negative infinity. So I've just been teaching it as always to use negative 1E99, E99, even if that doesn't logically make sense, and 105, and then the mean and standard deviation stay the same, and 0.2444. And just to try out, make sure that I'm correct, that it gives you the same thing with 0, I'm just going to go back and keep everything else the same. And you get the exact same number either way. So that's fortunate. So they can do whichever one makes more sense to them. And then we've got probability that a randomly chosen tree is between 88 and 98 inches tall. So that's just like we did in 7.1 with the between, that we make the lower whatever the smaller number is and the upper whatever the larger number is. Keep the mean and standard deviation the same, and get the answer there. And so these are all quite straightforward, actually. We've got others that are essentially doing the same thing, either looking for proportion or percentile. And if it ever comes up, is it appropriate to use the normal distribution? It needs to be a sample size of 30. And so you just answer yes or no, depending on whether the sample size is more or less than 30. So you can see that one, it was no, and this one, it was yes, because the sample size is 37. And then if it is, then you go on to do other questions about it that are done the same way as the previous ones. What I had back when I audited the class, 7.2 and 7.3 were combined. They no longer usually are. So what I have here is where it starts being the 7.3 problems. And only one thing changes here, is that now instead of having a probability of, or if you draw one thing at random, now we have a sample size to take into consideration. And so that changes how we enter the standard deviation. So here we've got, okay, what's the probability? Means we're going to be using normal CDF. And less than 481 means our lower bound is negative 1E99. And upper bound is 481. Our mean is still going to be just enter the mean from the problem, 498. And standard deviation is 112. But now, since we have a sample size of 63, we have to adjust our standard deviation to account for that. And so we divide by the square root of the sample size. So now for our standard deviation, we do the given standard deviation of 112. And then right here on this line, we do divided by square root. So second x squared, sample size 63. And you don't actually need to enter that closing parentheses there, I've found. So there you go, and it just spits out your answer. So that's fine. If you have the percentile, it's the same adjustment. So second var's inverse norm, area 65th percentile, so the area is 0.65. Mean is 498. And the standard deviation, again, we're going to divide by square root of the sample size. So 112 divided by square root of 63. And left if you have that option. And, oh, I did something wrong. Interesting. Oh, it looks like it was trying to square root the word left. That is probably not the case in a regular calculator. I think it's just because it's this online one, but let me go and fix it, and I think I probably just need to put that closing parenthesis in there. But in the regular handheld calculator, it won't give you that error doing what I did now. So it's 503 is going to be the answer for the 65th percentile. Would it be unusual if the mean were greater than 510? So then you're going to find the probability that it's greater than 510. And if it is less than 0.05, then it is unusual. If it's more than 0.05, it's not unusual, just like in the previous sections. And then when you get to part 5, they kind of throw you a loop there. Because now it suddenly is reverting back to being an individual. So just when you've gotten used to dividing by the square root of the sample size, now you're back to talking about an individual, and you no longer have a sample of 63, even though at the top of the problem they're talking about that sample of 63. And this always shows up in part 5 whenever there's a 5-part problem. So it's easy to realize, to look for it. Otherwise, it's just so easy to get into the habit of dividing by the square root of the sample size that you get down here and you're just picking out the number, and you forget that this one is asking about an individual. So I just always tell students to be on the lookout for, in the 5-part problems, be on the lookout for part 5 and do it then without dividing by the square root of the sample size. So then it goes back to greater than 510. So 510. At this point, it's exactly like what they were doing for section 7.2. So 510 or higher, so the upper limit is 1E99. The mean is 498. Standard deviation is 112. But we just enter 112. We don't divide by square root of 63. Paste, enter, and it's 0.46 or thereabouts. And number 8. So it's asking, is it unusual? And since that is more than 0.05, then no, it is not unusual. So I think that's all that comes up in these. Yeah, sample mean. If it says sample mean, then you're dividing by the sample size, sample mean. And if it says unusual, then you're not dividing by the sample size. And that's the only variations in these. Yep, that's it. Okay, so that is all for chapter 7.